so today we're going to look at how to do this with definite integrals. So these problems, I've picked a couple that are a little bit more difficult problems because those are probably ones we need more practice with. Some of the ones on the homework are going to be pretty simple. They won't be ones you have to necessarily do UDU substitution with. But we're going to talk about how we can change our variables for definite integrals. And so, change of variables for definite integrals. Okay, basically it means we're going to switch everything to u's and we're never going to go back to x's. So, on the problems that you were doing last night and the ones we've done so far, you switch to the u, but you have to switch back to x's because it's infinite integration. Your expression has to give you a value from, or give you the general equation, which has to have an x in it. Whenever we do definite integration, our answer is going to be a number. It's the area under this curve from 0 to 1. So our answer is going to be a number. So we're going to look at a way that we can do this so we don't ever have to switch back to the x's. So, looking at this formula here, in this formula, your g of x is your inside function. You can think of that as your u. And then so the g prime of dx, that part is your du. So whenever we substitute here and turn our g of x into the u, and our g prime of x dx into the du, in order to not have to ever switch back to x's, we can take our a and our b, whatever numbers those are, and plug them into our u formula. So g of a and g of b. Here, that'll make, I think, more sense once we do a problem. It's pretty simple when we do a problem. There. And then, once we do that, we don't ever have to go back to the x's. So there are two ways that they will give you these problems on the exam. Number one, it'll just be a straight definite integral. You'll have the answer. So the answer might be 7 or 10 or 5/8 or something like that. In those cases, you can go back to x's if you want. The other way, you'll probably see at least one of these. It will be on multiple choice, and they will tell you what to use for the u, and it won't give you the answer. It'll just give you the equation rewritten. So I'll show you kind of what that's going to look like as we go on. So, if we look at this equation that we have here, the integral from 0 to 1 of x times x squared plus 1 to the third dx. Thomas, what should we use for our u for this equation? Good. So u would equal x squared plus 1. So du is 2x dx. A lot of you guys are not putting the dx, put the dx with it. So, this is not one of the more difficult ones you guys had last night because you already have this x out here. All you need is a 2. But if you put a 2 here, you have to put a 1/2 out front. So, if we substitute in this stuff right here is our u, and then this 2x dx right here, that's our du. So we will have 1/2 integral u to the third du. Now I didn't do anything with my limits of integration yet. We still have to do that. Are we okay with all of this? This is what we've been working on the last few days. Okay, so you do have two ways that you can do this problem. So whenever I have this integrated from 0 to 1, all of my variables here were x. So this was telling me it's integrating from x equals 0 to x equals 1. All right. So I do have the option I would not write this down because this is not the quickest way to do it. I could do x equals 0 and x equals 1 here. But if I write 0 and 1, I've got to put the x equals and the x equals there. Because now my equation is in terms of u. So if I put numbers here, it would be assumed that those numbers are u's, not x's. So the quickest way to do this problem is to just leave your x's in the dust altogether by doing this. So if u equals x squared plus 1, I can change this x value right here to a u value just by plugging that number in. So u will equal 0 squared plus 1. So I'm taking that limit, I'm plugging it in here. That's going to give me 1. So I'll use 1 as my lower limit. And I will do that same thing with the upper limit. So I'll do 1 squared plus 1, which will give me 2. And I will use that here as my upper limit. So when I write that, it is understood now, because I'm not putting an x equals or anything, it's understood that u equals 1 and u equals 2. You're taking, like for the, lower one's on the bottom, and so you plug it into u, that'll go on the bottom. That upper one is on the top, so it gets plugged in here, and then you'll put that on the top, whatever you get there. Sometimes it might even create a situation where you got it like upside down, like you might get a 2 whenever you plug it into the lower limit and a -3 on the top. So sometimes it might even make it kind of backwards, but it'll work out in the end. So what is good about doing that is, so now when we integrate, we're just going to integrate like we've been doing. We'll get u to the 4th power, divide out front by 1/4. Don't forget that 1/2 that was out there. And we will evaluate this from 1 to 2. And so since this is in terms of u, we don't ever have to go back to x's. We don't have to plug the x's back in. So we could just do, the 1/8 will be here, and then we could do our, use a bracket right here. We got u to the 4th, so that's going to be 2 to the 4th minus 2 to the 1st. And so I've got 1/8 times 16 minus 2. So that'll be 14 over 8, which will reduce to 7 over 4. It's not. Sorry, I put that in completely wrong. That should be a 1 right there. This is wrong. Sorry. Because I don't know what I'm doing. You're plugging in 1 to the 4th there. It should be 1. You'll get 15 over 8. That's better. Yeah, so you're plugging in 2 into the u to the 4th, and then you're plugging in 1 into the u to the 4th. I just messed that up badly whenever I plugged the numbers in. There is no plus c on this one because it is a definite integral. So if we put a plus c, you'd end up with a positive c and a negative c, and they cancel each other out. So you don't have to put plus c's when you're doing definite integrals, the ones that have the limits, the numbers for your limits. Good question, though. Okay, now let me show you what the other option is just real quick, just so you could see what you could do, but I don't like to. So like if we did it like this, if we did not change our limits, we'd have 0 and 1, but we would need to put x equals and x equals right here. They don't even really love for you to do that, but you could get away with it. And then we would have u to the 3rd du. So if you did this the other way, you would have to do 1/2. You would do still the same thing, 1/4 u to the 4th. And you're integrating from x equals 0 and x equals 1. So you would have to plug your x back in. You'd get 1/8, and then your u is x squared plus 1 to the 4th. Now, since I'm using x's, I don't have to put x equals 0 and x equals 1, but that's what it means there. And so then you'd have to do 1/8 times 1 squared plus 1 to the 4th power minus 1 squared, no, I'm sorry, 0 squared plus 1 to the 4th power, like this. This is going to give you 15/8 in the end, but it's just a little more work to do than doing 2 to the 4th minus 1 to the 4th. Yeah, so it just makes it a little easier to do. You usually have small numbers that are easy to plug into your u, whereas if you do it down here, it's kind of more jumbled up. So if I don't change, what I was showing here is if you don't change your limits, if you leave them 0 and 1 where they're still x's, then that means you have to go back to x's in the end. So your u, you would have to plug in the x squared plus 1 like we did on the other problems, which you have to do on those problems. You can't quit doing that on those other problems because they're general integration. But for definite integrals, if we switch to u's, then we don't have to go back to this x stuff, which usually makes it more complicated at the end. Does that make sense? Okay, so we're just going to do one more together, and then I'm going to have you guys mostly do work today for this because I want you to get plenty of practice. Okay, this one's one of those like last night. This one's going to be a little more complicated. Okay, so what would we use for our u here? 2x minus 1, which means du is 2 dx, just no x, just the dx. So I need a 2 right here, a 1/2 out front. I also have the x in the numerator. Yep, so I've got to solve for x here. So I've got u equals 2x minus 1, so I'd add the 1. U plus 1 would equal 2x. I'd divide by 2. So x is u plus 1 over 2. So if we're plugging everything in, we're going to plug in this u plus 1 over 2 for my x. This piece right here is my u. And this piece right here is my du. So it will look like this. I'll have u plus 1 over 2 over, 1/2 out here. And then square root of u du. Now, I haven't done anything with my limits yet. But we've replaced what we need to here. I'm going to switch to u's and never go back. A lot of times you'll also see this as just a straight setup problem. So if you see it as a setup problem, there will be an answer choice that looks like this, where 1 and 5 are still your limits, where the limits have not been changed. It will be wrong. You will not choose that one. The one that you will choose will have the limits changed. So if we take this bottom limit, u would equal 2 times 1 minus 1, which is 2 minus 1, which is actually still just 1. So the bottom one's still going to be 1. And then we'll take the top limit. It will be 2 times 5 minus 1. So 10 minus 1 will get 9 for that top limit. So what you'll see if it's multiple choice is they will tell you that 2x minus 1 is the u. You'll see an answer choice that looks like this, but goes from 1 to 9. There'll also be an answer choice somewhere that looks like this and goes from 1 to 5. You would rule out the one that's 1 to 5 because the limits have not been changed on that. So there. Okay, are we all right here? But the other option is they might ask you to solve it the whole way, which is what we're going to do here. This square root of u, I could move it up to the top. So that would be u to the negative 1/2 times u plus 1 over 2. And we would just distribute that u to the negative 1/2. So I would get u to the positive 1/2 plus u to the negative 1/2 over 2 du. We're going to take 2 out here because it's just a coefficient, and that way it'll be out of our way. So we get 1/4 integral from 1 to 9 of u to the 1/2 plus u to the negative 1/2 du. We're not going to move it. We're just going to integrate using power rule because these are separated out by a plus sign. We don't have any fractions or anything left. This is not raised to a power. So we'll do u to the 3/2. So let's leave the 1/4 out here, the bracket here. Then we got to divide out front by the 3/2, which is actually just going to flip the fraction. So we'll have 2/3. And then we'll have u to the 1/2. We will divide out front by the 1/2, which will just flip the fraction and give us 2. And we're integrating this from 1 to 9. No plus c, because it's a definite integral. Although if you put the plus c, it's actually okay, because the plus c will cancel with a minus c whenever you plug everything in, and it'll work out, but it's unnecessary here. All right, at this point. So now it's just arithmetic from here, but it's a place that we mess up a lot of times. I don't think the fractions get too crazy on this. I think this is something you would actually see on the AP exam. So you've got, I'm going to change this, actually, I need to set parentheses. I'm going to change this to a square root of 9 to the 3rd, right? Because 3/2, that'd be the square root of u to the 3rd. And here, this will just be square root of u. Plus 2 square root of 9. Minus, and these parentheses I'm putting here are important because you have a minus sign in between. So if you don't distribute that negative correctly, you're going to miss it. So we need 2/3 square root of 1 to the 3rd plus 2 square root of 1. So, yeah. All right, so, what is the square root of 9 to the 3rd going to be? We remember for these, instead of thinking like doing 9 to the 3rd power, because that's going to be like a big number, think of it like this, the square root of 9 to the 3rd. Because we talked about that the other day. We could write this either way. And so, what's square root of 9?
3.
3. What's 3 to the 3rd? 27. Much easier than getting 700 and something and then taking the square root of it, which you probably don't even know anyway, right? Because it would be 27. So, I have 2/3 times 27. Plus, this is going to be 2 times 3, which will give us 6. Keep those parentheses there. And then we got 2/3 times 1, which is just going to be 2/3, plus 2. And so, when we multiply that 2/3 times 27, I would reduce, if by 3 here and make that a 9. So you're going to get 18 plus 6 minus 2/3. Actually, sorry with you guys if I go ahead and distribute that negative. That way I don't have to. We'll go ahead and distribute this negative here. So I got negative 2/3 minus 2. So if I do 18 plus 6 minus 2, that's going to give us 22 minus 2/3. Which if I multiply, still got the 1/4. Still got the, did I lose something? Got to subtract this 2 over here on the end. Yeah. And then so this is going to be 66 over 3 minus 2 over 3. Which is going to give us 64 over 3, which is multiplied by 1/4. So we can divide by 4 there, right? Or just get 64 over 12 and reduce. What's 64 divided by 4? 16. 16. So we get 16 over 3. You may see something like this on the AP exam. I think it's the upper limits of the arithmetic they would ask you to do. It probably would not get much more involved than this right here. Most questions are going to probably have a little less than this as far as all the fractions go. But you might see something sort of up to this. Keep in mind, if this were AP exam and it was free response, we could have stopped here on FRQ. As long as you don't need to go, as long as you don't need to do anything else with it. The only thing is, be really careful with your parentheses, because if you leave off this second set of parentheses right here, your answer's wrong. So if you don't have this second set of parentheses, your answer's wrong because you're not distributing that negative to both of those. So you got to be careful with that if you do that. Yes. Okay. Questions? Alright, so we've got a little over 20 minutes. Your assignment is going to be page 297, 55 through 64. They are not all as long as the last problem we just did. Some of them are going to be quicker. I don't think any of them should be longer. Hold on. I don't think that's the right page. Let me look. I think that's from the old book. let me check Canvas. I must not have changed it here. Okay, that's the wrong page. I put it on Canvas. I remember doing this now. I've got the right assignment. Let's see. Okay, it is actually page 342. Same page we've been doing all this work from. And 71 through 82. Get a bathroom pass? Oh, no.
So, you plug in the endpoints into the view.
Yes.
And then you subtract it with the other endpoint.
Right, so you're plugging in like the 9 into this right here, and subtracting whenever you plug in 1 into this right here. Yeah.
So that's what all
Yeah, yeah. I tell you what, there's a lot of E's at the end. Let's make it stop at 80 instead of 80. Yeah, instead of 82. 71. Let's see. Page 342. 71 to 80. I think that'll still give you significant practice without causing you to have to do excessive E stuff, even though E's are a little bit easier. But. All right, so you got 20 minutes. Make sure you're using your time wisely.